objective for this integrated project in terms of PSLE is to identify the different types of hazards involved in the production of acetylene and how to overcome those hazards. We have used the partial oxidation process in order to produce acetylene, and the different types of equipment we have used are, for instance, absorbers, strippers, and also mixers. Hazards are a source by which harm can be inflicted onto a certain individual, and that harm might even cause death. That is why we have to reduce these hazards. Hazard analysis is also carried out to identify errors regarding certain equipment and how those errors can be solved. Hazard uses certain guide words in order to assess situations, and that guide words allow us to identify what errors can be solved in certain steps in order to prevent or reduce the amount of hazards in the overall activities. Thank you very much.
There are several hazards that have been identified when using absorber in this acetylene production. First is the fire or explosion hazard. The absorber is fed with pure acetone, which is a selective solvent used to remove acetylene, and it is highly flammable. The main component inside the absorber itself is impure acetylene, which has other components like carbon dioxide, which are under pressure gases, which means they are prone to being explosive if heated. Second is the corrosion hazard. When acetylene is involved in a fire, it may produce hazardous or toxic fumes such as carbon monoxide, which corrodes metal at higher pressure. Third is impurities hazard. Since acetone is used as a solvent, it may be carried over as an impurity in this production. Fourth and lastly, fifth are overheating and overpressurization hazards. The absorber has to be operated at an appropriate temperature and pressure to avoid additional heating, which may affect the efficiency of the absorber.
Okay, so now I'll be explaining on the HAZOP study based on the separation unit, which is the absorber column, by using the HAZOP guide word. For the first process parameter is the temperature. The guide word is low temperature. The possible consequences is due to the too much cooling power from the cooler, and the possible consequences is it will result in pressure drop of the absorber column. The action required is to install a low temperature alarm, install a low pressure alarm, and also check maintenance procedure and schedule regularly. For the next guide word is high temperature. High temperature may be caused by not enough cooling power from the cooler. It may be also due to the high feed temperature of the absorber column, and it will lead to overheated absorber column, and any available ignition source could cause an explosion. The solubility of the gas will be low. There will be loss of solvent due to the evaporation of the solvent, and also the pressure of the absorber column will rise. What we need to do in order to prevent this is we need to install a high temperature alarm, a high pressure alarm, check maintenance procedure and schedule regularly, and ensure the cooler unit is well maintained with adequate control. The second process parameter is pressure. For low pressure may be caused due to the pipe is leaking, or there is not enough power from the compressor, also due to the absorber is overcooled. It will lead to pressure in the system drop, and also resulting in lower amount of gas dissolved in the liquid, which is also mean lower solubility. And the total pressure will also lead to the decrease of mass transfer area, and also the low total pressure encourage the solvent to evaporate, causes the solvent loss. And what we need to do in order to prevent this is we need to install a low pressure alarm, we need to install a low temperature alarm, we need to check maintenance procedure and schedule regularly. For the second guide word, which is high pressure. High pressure is because of the absorber column is overheated, and also thermal expansion occur from the absorber column. It will make the absorber column over pressure and cause a rupture of the column. Any available ignition source will also cause an explosion. So in order to avoid that, we need to install a pressure relief valve, provide thermal expansion relief, install a high pressure alarm, install a high temperature alarm, and also, like usual, check maintenance procedure and schedule regularly. For the third process parameter that we have found is flow. The guide word is no, and the deviation is no flow. This is causes by the pipe blockage or also a compressor failure, and it will lead to no operation occur in the absorber column, and also the column will dry out. So in order to prevent that, we need to install a low level alarm, check maintenance procedure and schedule regularly, and make a bypass. For the second guide word, which is less flow. Less flow is due to the pipe blockage and leakage, and also from the compressor failure. It will also result in the column dries out and change in the output quality. Install a low level alarm, check maintenance procedure and schedule, and make a bypass can prevent that. And the last guide word for the process parameter of flow is more. The deviation is more flow. More flow occur at the absorber column is due to the compressor capacity is increased to its maximum. It will lead to flooding in the column and also changes in the output quality. We need to install a high level alarm, install a control system, and also check maintenance procedure and schedule regularly in order to prevent those from happening. Okay, for the fourth process parameter, which is the integrity. The guide word for integrity is no. And the deviation for integrity process parameter is loss of containment. Loss of containment occur due to the mechanical damage to the absorber, and also installation error, and also improperly selected material. This will lead to any available ignition source will cause an explosion or fire. It will create a pollution to the environment, and also it will cause process safety incidents. We need to avoid all of these things by always check maintenance procedure and schedule regularly. The last process parameter that we have found for our project is the fifth one, which is corrosion. The guide word for corrosion is as well as, and its deviation is the absorber corrosion. Absorber corrosion happens due to the presence of impurities that will cause corrosion, and also it is due to the use of stainless steel. It will lead to maintenance difficulties due to the presence of corrosion debris in the absorber column. It also will disrupt the absorption process and efficiency, and also the composition of the chemicals. And also, it will change the output quality. In order to prevent that, all we need to do is we need to check the maintenance procedure and schedule regularly every time. Okay.
I'm explaining about the recommendation to improve the safety aspect of an absorber. Few suggested recommendations are: first, as the absorber can be potentially overpressurized or depressurized, an automatic operated valve system can be installed to stop the flow upon detection of a dangerous event. The inlet of the absorber also deals with high temperature, so a backup cooling water system can be used for the event of a power outage or a pump failure. Next, for the material selection, stainless steel can be chosen as it contains chromium, which enacts the ability to form a passive layer that makes it an excellent corrosion-resistant material. Lastly, scheduled maintenance inspection should be examined prior to the operation. These are the corrective and preventive action of an equipment for the safety of the plant.
In conclusion, we have successfully achieved and accomplished the objective of this project, which is to identify the potential hazards and also to look ways on how to prevent all those hazards. In this project, the separation unit chosen is the absorber. We have listed down several hazards that might occur in absorber, such as fire hazards, explosion hazard, and also corrosion hazard. Other than that, we have done and identified the hazard to study the causes, the consequences, and also the action that need to be taken to overcome or to reduce the hazard. Lastly, we have suggested a few recommendations to increase the safety of the absorber. Thank you.
Okay, thank you everyone. Stay safe. Bye.